Greetings. This is my attempt to solve example problem 10 from the Mathematical Toolbox latest video. We have a stochastic differential equation. Here we're given that the initial condition is x sub 0 equals 1. So we need to find the equation for x sub t. I have notes here from where I did example 21 along with him that I'm going to use to help try to guide me through this. I don't have personal experience with E2 calculus or the stochastic differential equations. I have done differential equations in the past, but not the specific style of differentials. So this is, I'm learning this through the videos posted by the Mathematical Toolbox. The first thing that I need to find is rho sub t. So we're going to have e to the negative integral from 0 to t of the g square term, which is the coefficient of x sub t here. So we're going to want alpha squared. Or sorry, just alpha on the first one, alpha dw sub s plus 1/2 integral from 0 to t of the alpha squared, and then ds. And then we want to simplify that. And that's going to give me e to the alpha squared t half minus alpha w sub t now. Then we want to do the derivative of this. So this is going to give me another term here. This should be alpha squared rho sub t dt minus alpha rho sub t dwt. And skipping steps and getting from here to here, we generate 3 terms. 2 of them add together to eliminate this half piece because 2 halves make a whole. And then the next thing after this, we want to multiply this derivative by x sub t. And we don't know what x sub t is yet, so we're just literally going to put x sub t terms into this. So x sub t d rho t is going to be alpha squared x sub t rho sub t dt minus alpha x sub t rho sub t dwt. All right, this should be important later that we were going to want to reference because we'll use parts of some of these things for substitutions later in the calculation. The next thing that we want to do is we want to multiply the derivative of x sub t, which is our original given, by the derivative of rho. So this thing times this thing. Since this has 2 terms and this has 2 terms, it's a matter of double distribution. and then we're going to have to simplify that. So this very first term times this, and we're going to have two of these dt, so that's dt squared, and that's going to be a special term here. And then this very first term times this as well, so we're going to add that in here. So it's going to give me alpha cubed rho sub t x sub 2, and then dt d w sub t. And then this also is a special term that's going to play a role in here, and we're going to multiply by this second piece here. So alpha rho sub t dw sub t times this x sub t dt. Again, I have this dw dt here. That's going to be an important term. And then again, alpha rho sub t dwt, and then times this, so that squares that, and adds an x sub t in here. All right, so he tells us that there's some identities. If you go back and watch, there's actually two earlier videos that I could find in the series that reference this. I also asked the question because I didn't recall that, so I asked a question and got some help on that. The dt dw goes to 0, so this term right here is going to go to 0, and this term right here is going to go to 0. The dt squared is in one of his earliest videos in the series on E2 calculus, and this is also going to go to 0. So we have 0, 0, 0 here, leaving this last term. That's the only one that survives. So we can erase the rest of this and keep this term. All right, we've got that cleaned up. The next term that we are looking for is rho sub t dx sub t. We have, again, this is the original, and rho was calculated here, but we're not going to put this expression in here. We're just going to put the rho in here again. These other things that we've done up here, they're all in terms of rho as the symbol and not the expression, and we're going to look for some substitutions to do. So if we put this form in, it's going to cause some confusion looking for the pattern that we're going to need for substitution. So we're just going to essentially insert a rho sub p into each of these. All right, so now that we have that established, if we look back in here, we can see we have the alpha, the rho, the x sub t, and the dw sub t right here. So if we do a little bit of algebra here, move this term to the other side, and then multiply by -1, we can drop that into here as a substitution. All right, so we can bring this in here, and then what else can we do? We also have this term here. I feel like I'm missing something here. I feel like some of these that we've done in the past, there was a plus minus situation here. I'll have to take a look at this. All right, I had to go back and review this calculation. I had missed that this term should be squared, and that I had the dw sub t times dw sub t, which those terms multiplied together gives me dt. So I actually had two mistakes here, and it probably wasn't when I transferred it. I probably had written it down wrong originally and then transferred it wrong. So this term looks different. I went ahead and did the substitution in for here so that rho sub t dx sub t is now this, where I've taken this term out and substituted in here. So we have this. And now if we look, this term and this term are the same except for a sign. So if I multiply on both sides by the negative 1, that means that this positive version is equal to the negative version of this. So we can substitute that in for here. So this will be negative dx sub t d rho sub t. All right, and then these other terms were going to be the same here. All right, and then we could probably going to need to switch some things on sides here. We definitely want to have this term here, and we need this term here, and we need this term here. So we could push this term to the other side and bring this in, because what we're doing is we're trying to get the form that we need so that we have the derivative of x sub t rho sub t is equal to an expression here. All right, I've got this part here, and I'm wondering if I'm slightly lost here. This should evaluate to x sub t rho sub t. This is going to be x sub 0, but this is going to 1. Rho sub 0 plus, this needs to be rewritten in terms of s. So x sub s, and then these terms are replaced with e to the alpha squared s over 2 minus alpha w sub s ds. And then we want to multiply both sides by 1 over rho sub t, so that x sub t is equal to, this is rho sub 0. I'm not sure where this is supposed to evaluate to. I'm going to leave it in here with a rho sub t underneath of it. Again, because I don't know where this is supposed to go. And then I'm going to put my inverse row here, my reciprocal row. There. And then I'm leaving this integration. Oh, this is integrated from 0 to t. Should put those terms in there. X sub s e to the alpha squared s 2 minus alpha w sub s ds. And I don't feel good about this solution, especially because I ended up with this x sub s term in here. I feel it's self-referential to what we're actually trying to find. I think maybe they're with the integration by parts in the stochastic system that this probably breaks down somewhere else, and I don't know where to go with that. But right now, this is where I am with this. I've consulted with Mathematical Toolbox at this point, and it has been brought to my attention that I missed some of the beauty of this problem. When I get down to here, I proceeded to integrate as is and found myself with self-referential term, which indicated to me that there was some kind of a mistake, that I missed something, and that was true. Because the beauty of this is, if I divide both sides by x sub t rho sub t, then I have the classic du over u form that we would have for a logarithm, and I've totally missed that. So that's the next step that I need to do. We end up with this classic form for logarithm here when we integrate. So we want to go ahead and integrate this with respect to s. So this is going to be from 0 to t ds is equal to integration from 0 to t dx sub s rho sub s over x sub s rho sub s. So this side evaluates out to t, and the right hand side evaluates out to the log of x sub t rho sub t minus the log of x sub 0 rho sub 0. And then we're going to add this onto the other side so that we have t plus the log of x sub 0 rho sub 0 is equal to the log of x sub t rho sub t. Then we want to well, there's a couple options that we could do. We could observe that our initial condition is that x sub 0 is 1. Rho sub 0 also evaluates out to 1. So this is the log of 1 times 1, or the log of 1, which is going to go to 0. So that term can be ignored altogether. And then we can push these into the exponent position of e to cancel this logarithm here. So we have e to the t is equal to x sub t rho sub t, and then we're going to divide rho on both sides, but we're going to substitute this value for rho that we determined earlier. So x sub t is going to be e to the t over e to the alpha squared t half minus alpha w sub t that we have here. And then bringing this up to linear form, we have finally that x sub t is going to be t plus alpha w sub t minus alpha squared t halves, all as the exponent of e. So this is our final value for x sub t. This has been an interesting problem to work on. It has been outside of what I normally do, so it was nice to be able to work through the video and try to catch the pieces that I needed to be able to work my way through this stochastic problem. It's been nice to be able to work on something that I don't normally work on. Hopefully you find some mathematics in your area of the world to enjoy. Cheerful calculations.